Yesterday, we have completed our discussion about resistivity, conductivity, right? Resistivity, conductivity. So here, depending on R value, they are depending on R value. So individually, different materials has different resistance values. If you want to prepare a particular wire having the particular resistance, how do you prepare? How do you make? How you are manufactured? Right? So here to prepare or to manufacture a wire having the particular resistance, just you are combining them, right? Combining them with different materials. They are called as a combination of different metals, right? Used in only one substance, that is called here alloying. So alloying is a process in which you are combining metals in different ratios, right? So that is alloying. For example, here nichrome is given, right? What is nichrome here? Nichrome is a combination of nickel, chromium, and manganese. Nichrome is a combination of nickel, chromium, and manganese. So in different percentages, they are combined. Likewise, you have different substances which are combined in a different, sorry here, nichrome is a combination of nickel, chromium, and iron. Nickel, chromium, and iron. So then one more is there, manganese. Right? Manganese is not a pure metal. It is combination of different metals which contains copper, manganese, and nickel. Copper, manganese, and nickel. So in different various percentages they are combined. So what happens when they combine? Here individually, if you observe nickel resistivity, it is 6.99 into 10 to the power of minus 8. Chromium, if you observe, there is a chromium. Chromium is not given. Okay, iron. Here is a 1.00 into 10 to the power of minus 7. Right. So by combination of nickel, chromium, and manganese, nickel, chromium, and iron, you are changing that resistivity nearly 30 to 100 times, right? That various resistance values you are able to give that particular material. You are able to change the material resistivity value, right? So that's why you are combining the metals in different ratios. So that alloys are having the different resistivity values, right? So concentrate on this table information, right? Now we'll discuss about another, that is about electric circuits. So what is an electric circuit? What is an electric circuit? So simple, circuit is a complete path, right? Complete path for the flow of charges, right? So here it is two types, right? Maybe opened and the other is closed. So here to open or close, we are using a device that is here switch we are using, right? To make the circuit either open or closed one using the switch. Okay, so here switch is a device which can operate the circuit to make it open or closed easily. Okay, so here, right, up to now we discussed only simple circuits that which consist only one component, bulb, one component, cell, one of the component, switch, and connecting wires, right? Suppose if I give you to connect only in the single circuit many bulbs, suppose here 3 bulbs are given. How do you connect? Right? So using single path or using many paths. So many possibilities are there, right? So that components are connected using the single path or many paths. So by that combination or connections, by the connections, you are allowing the electricity, that current through all the components only in single path, in a single way, or you are able to allow them individual paths from the single source by maintaining individual paths, or you are able to create multiple paths, single or individual, multiple paths. Shall we check them once? Here I have three bulbs, right? I have three bulbs. The three bulbs you are able to connect only single path allowed from the battery using one switch, right? So how can I connect only in the single path? So here I am connecting like this, right? Then one more possibility is there, individual paths through the bulbs here. Individually the current is going to be allowed through that, right? So using only one battery here, I am connecting these all the three bulbs. So I can arrange the battery is like this. So okay, here you may need a key also. Okay, here you can give the key. So like this you are able to connect. Okay, here individual paths maintained in second diagram. Individual paths maintained, right? In the first one, I maintained only one path, right? Only one path. So is there any disadvantage in the first one? Is it having any disadvantage? So that disadvantage is there. Suppose here they have the filaments. If one of the filament broken, what happens? Anyone answer me? If one of the filament of the bulb broken, what happens? The circuit will be work like closed one, or the circuit becomes open circuit if one of the filament is broken. For example, here in the third, suppose in the third bulb, the filament expected is broken. The third bulb has no filament. What happens? Will it work like a closed one? When I close this switch is connected, then the current passes through this? No. Why? Here, from the battery, the current started to move along the wire, right? Then it passes through this second one, it passes through this. Then what about the third one? There is no connection here, right? So will not pass. The current will not pass. So here the disadvantage is, if one is failed to work, remaining also do not work. Then what about in the second? Here the current starts in this way, right? Here it can divide. It goes in three ways. Goes in three ways. Suppose here the filament is broken in this, the current stopped here. Okay, here if the filament is there, the current passes through it like this. Then I'm expecting third one also broken, so the current stops here. So two failed, but the third one works as is. No effect on the third one. If two broken, third one works. If one broken, remaining two works. Right? If it is broken with all the filaments, then only it stops working. So this is the benefit in the last one. So advantage. Right? Many of them failed. If one is working, that will work. It will what not depend on the other. Independent. It works independently, not depend on any other. Right? So that is here you need to observe in these parts. Then one more possibility is there. One of them connected in the single path, then remaining two I am connecting in different paths individually. So that same number of bulbs are connecting with the battery. In this case, what happens? Suppose here I am expecting this one not working. What about the remaining two? They can work. Okay. Suppose here I am expecting this one not working, broken fuse. Then remaining two works. Okay, now I am expecting the first one is failed to work. What about the remaining else? Do not work. Why? So here current is allowed through this bulb, right, into the remaining second and third bulb. So these are the observation points while you are connecting with the battery, right? So they are not connected individually with the battery. If you connect them individually with the battery, they can work independently without depending on the other components of electricity except the battery, right? So this you need to understand. So here, now we are trying to understand the types of circuits here based on the connections. Types of circuits based on the connections. So here, if you maintain only single path, right, that is called here simple to remember. It started with S. So I'm giving the name for that single path series combination. Right? To remember this code, right? Series combination meaning is different. All the electric components are connected in a series combination when you observe this point. They are said to be in series combination when you observe one point. So here all the terminals of the electric components are connected by using a single wire, only single path, right? So this is called series combination. So in this, the same amount of current will be allowed to pass through all the components, right? All the components, same amount of current will be allowed here, right? Then here another one is there, right? Another one is there. What is that here? Simply maintaining individual paths. Maintaining individual paths. So here, if you maintain individual paths from the battery, then they are said to be here in a parallel combination, right? Parallel combination. So simply I am giving you one keyword to remember, or two keyword for identifying the circuits. This keyword help you to identify the circuits. If you find all these two single paths, right? Single path from the battery, and they may have individual paths from one of the source or one of the component. Then it is said to be multiple combination, as you observe. So are you clear about these circuits? What I am given the diagrams and what I am given the keywords. Are you able to identify the circuit types? Give me your quick response. everyone. If there is any confusion, immediately ask me. Tejaswini, no response from you. Any doubts? No doubts. Okay. Let us understand here about resistance. What happens to the resistance if that components of electricity, right? Components of electric circuit, electricity are connected in a different combination, are connected in series or in a parallel, right? So what happens to the resistance? So that we are understanding using here simple circuit, right? So here simple, you can make a circuit using 3 bulbs, using 1 switch, right? And use multimeter to measure current and to measure voltage, right? To measure the current and to measure the voltage. If you want, you can measure the resistance also individually from each. Okay, here, how to make a circuit? Simple, you are using a battery. It may be 6 volts, 9 volts, whatever it may be available to you. Then use not LED bulbs, use torchlight bulbs, right? Torchlight bulbs. Here, why? If you use LED bulb, that is semiconductor, it will maintain that amount of current passing through it same. It can adjust. So resistance remains same, right? Then simply here, if you use torchlight bulb, its resistance depends on the battery voltage. Suppose here LED bulbs, small terminals, right? So that LED bulbs will simply glow for any voltage. Small voltage also can make the LED bulb to glow, right? Not the room bulbs, indicator bulbs. For example, in your TV remote, you have the indicator, red color light, or in your what laser lights, you may use see that red color bulbs. They are that type of bulbs will glow for a small voltage also, right? For any small current, they can glow. So that bulbs will not work out here. Then that torchlight bulbs I am connecting in a single part. So how to connect? So any bulb has 2 terminals. That 2 terminals of the bulbs are connecting here using only 1 wire, making into many pieces. So one of the piece is connected to the first terminal of the bulbs, then using the another piece of wires, second terminal of the first bulb is connected with the first terminal of the second bulb. Then second terminal of second bulb is connected with the third terminal, third bulb first terminal. Then third bulb second terminal is connected to the negative terminal of the battery, right? Then here you can arrange here switch. Okay, switch is arranged. Then connect an ammeter to measure the current, series combination. Then how to connect a voltmeter to measure the voltage allowed through individual bulb. So here the battery maintains something voltage. We don't know that voltage V. If you are taking 6 volts battery, 6 volts, 9 volt battery, 9 volt, 12 volts battery, 12 volts, according to that battery value. Then how to connect here voltmeter? Voltmeter always connected in parallel combination. If you want to measure here voltage of the battery, you can connect the terminals of the battery to the voltmeter like this. So it is said to be parallel combination. Independently it can work, right? Then through each bulb, connect the voltmeter as you see here. For the third bulb also, I am connecting like this. For the third bulb also, I am connecting like this, right? So here you can connect and measure the voltages allowed through each bulb and note down them V1, V2, V3, V1, V2, and V3 individual. So here voltage is measured V1, V2, V3, and compare the voltage of the battery after switch off, right? So individually, the voltage is allowed through the bulbs measured as V1, V2, and V3. Then current also you can measure in the same way. Connect in any gap between any two bulbs, right? So you will measure the current always constant in this combination of a circuit. So I is maintained constant through each end bulb itself, not bias itself. You are observing I is constant through any bulb. Then what about the voltages? You are observing here, it is varying. Voltage varied, but the current is remained same. What type of combination of circuit is this? Single path is maintained, right? Through the bulbs. Don't see the voltmeter, right? We are not discussing about the voltmeter here, only bulbs. Why bulbs are here? Bulbs are here nothing but resistor. How you can decide, sir, it is a resistor? Resistance is what? Obstructing the charges. So bulb filament can obstruct electrons passing through the filament, right? Electrons flow is obstructed through the filament of the bulb. So that's why here it can glow itself. Why not normal wire? Have you thought this one? If you think normal wire and the filament wire in the bulb, right? So that filament wire in the bulb is having the capacity of obstructing the charges is more comparing with your normal wire, copper or aluminum or any else, right? So that resistance is more for the filament. That's why I am saying here bulb is a resistor, right? Bulb is a resistor. So here I know the amount of current passing through it and I know the voltage, right? I know the voltage. So here current remains same. Current remain same through the circuit. So here simply V I measured through the battery. Then V1, V2, V3 are measured through individual bulbs here. Individual bulbs, we are measured that voltages and we got the different values. So that's why I'm given V1, V2, V3. Then try to make a relation between voltages here. What do you find? So individually, if you are comparing these voltages V1 with V, V2 with V, V3 and V. So what you are going to observe here, V always greater than V1, V greater than V2, V greater than V3. Then compare V1, V2, V3 also. You can make a relation. So every time you can find that relation, one is less than the other, right? So here, how to get this voltage, right? By adding this or by dividing one by the other or by taking the product or by taking the difference. So follow that fundamental operations. So one of the operation will give you final voltage. That is here sum of the individual voltages. Sum of the individual voltages give you the voltage equal to the battery, right? So I got a relation. What is here? That relation I got here, V is equals to V1 plus V2 plus V3. Then we know each bulb has filament. That filament hides the resistance differently. So that resistance, if you measure, you can find out that resistance also is R1, R2 and R3 values. Right? R1, R2, R3 values. Then here, just find out what is the voltage. V is equals to IR. What about V1 equal to? Using Ohm's law, we can write as I1 R1. We can write as V2 equal to I2 R2. V3 equal to I3 R3 using Ohm's law. So here, final resistance through the circuit is taken as R equal to R equivalent. Equivalent resistance or effective resistance, because of that all the bulbs connected in the circuit, right? So that resistance is allowed through the wires. So that resistance is taken in the overall circuit is here equivalent resistance or effective resistance. So finally, what I am able to write, V is equals to I is the total amount of current is allowed through the circuit, and R equivalent is the resistance allowed through the entire circuit. Then through the individual bulbs, the voltage V1 equal to voltage V1 is equal to, here what I got here, V1 equal to I1 is the, I is the current passing through the bulb. So current not divided, then amount of resistance is R1. So V1 equal to IR1. Then similarly, you can write the equation for V2 also using the amount of current passing through the bulb. That is here I1 current. Then next, I current. Then the resistance value is R2. Then V3 equal to similarly I R3. Then substitute in the relation this one. V equal to V1 plus V2 plus V3. Then here you are able to write the relation here as like this. So V equal to I R equivalent is equal to V1 IR1, V2 IR3, IR2, V3 is IR3. Then what is commonly available left side and right side? I is common. So I common and cancel. Then what is remains here? R equivalent equal to R1 plus R2 plus R3. So this is, I got equivalent resistance in the circuit by the combination of three bulbs. If many bulbs are connected, see here, how many bulbs are there? That many resistance are added here. If more than three there, what you can write the formula here? R equivalent equal to R1 plus R2 plus R3 plus dash 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 dash. As many resistors are connected. That means as many bulbs are connected in the circuit. As many bulbs are connected in the circuit. So this is the equivalent formula to find out the effective resistance in the series combination of bulbs. So not only the bulbs are called as resistors, any consumer, right, that which can use electrical energy to work. For example, bulb is working by using the electrical energy. Then fan is working by using the electrical energy, right? Electric heaters worked by using electrical energy. They are all called as here resistors. The consumers are known as here resistors, right? So this is the formula I am going to use when the resistors are connected in series combination. Are you clear about this formula derivation? Go to quick reaction. Are you clear about this derivation? Just I used one logic, measured the voltages through individual bulbs, and I tried to establish a relation between the voltages by observing the values, right? So what the voltage is given by the battery, that same voltage is given by the combination of individual voltages of bulbs here, V1, V2, V3, by the first bulb, second bulb, third bulb, right? So this helped me to write a relation between the individual resistances and the resistance of the entire circuit called equivalent resistance or effective resistance. So that I got formula here. So look at in your textbook that the derivation part in the activity 6. So we got a relation V equal to V1 plus V2 plus V3 is given here, equation 1. Then individually I am measuring the voltage and finally finding the voltage between the ends of first bulb first terminal to the third bulb second terminal. Then I got the voltage, sum of the voltages of individual bulbs given here, V1, V2, V3. So V1 plus V2 plus V3 that we measure. Then here substituting and solving it to get a relation that I got here. Simply R equivalent is equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So this is effective resistance formula, R equivalent equal to R1 plus R2 plus R3. So if you are clear, we will go to another combination. Just go to quick reaction. So remaining rest of the people not clear? No response. Only one person given. Right. Once again, you need to read it, follow thoroughly. Right. So there is one question for you. Here, you are connected resistors. In what combination here? Resistor symbol, we can use this one. Right. So 3 resistors are connected only in the single path using only one battery here and one switch, whatever it means. Suppose here one of the resistance is broken. What about the rest of the bulbs or resistors here? Rest of them. Do they work? Answer. Do they work? If one of the resistor is broken, do they work? No. Why? Here it works like an open circuit when you close the key also. It works like a open circuit. Suppose if I close key here, fuse already broken here, so it left gap. So the current reaches up to here, but it won't pass. So no current passing, no potential difference terminate between the terminals. So no current allowed through this. So one of the resistor breakdown, what happens here? Remaining also failed to work. So just you need to replace that where you observed that failure open. So that you need to fill up with a resistor, then it will be work. So this is about series combination and equivalent resistance. So I'm closing this meeting at here. Join immediately in the next meeting.